Problem number 4. An open manometer is filled with mercury. The mercury level is 10 millimeter higher on the side open to the atmosphere. What is the total pressure of the gas in kPa if the atmospheric pressure is given to be 100.8 kilopascal? So there are three scenarios that happens in the manometer. First is when the given liquid are at level with each other. So the one exposed to the atmosphere, this is the atmospheric side. So if the liquid in the manometer is at the same level, both on the side of the closed part of the manometer and the one exposed to the atmosphere, and if the fluid is at level with each other, meaning to say the pressure of the gas is equal to the pressure of the atmosphere or the atmospheric pressure. Next is if the liquid on the side of the atmospheric area is greater than the fluid on the side of the closed area, this means that the pressure of the gas is greater than the atmospheric pressure. And then next is kapag ang fluid naman on the side of the closed area is higher than that of the side being exposed to atmosphere. So if this is the case, the pressure of the gas is smaller than the atmospheric pressure. So in our problem, it says that the mercury level is 10 millimeter higher on the side open to the atmosphere. So we are on this case. So the question now is, what is the total pressure of the gas in kPa if atmospheric pressure is 100.8 kilopascal? So in this case, the pressure of the gas is simply the atmospheric pressure plus the height. And note also that we have here a conversion. 760 millimeter of mercury is equal to 101.325 kPa. So we need this conversion because definitely we cannot add the height of 10 millimeter with kilopascal. So we have to convert. Since this is our case, the pressure of the gas is simply the atmospheric pressure plus the height. So first is we have to convert the given atmospheric pressure 100.8 kPa. Let's convert it into millimeters so that we can add the height. So 108. So our conversion unit, this is 101.325 kPa. This is the equivalent is 760 millimeter of mercury. So your kPa and your kPa will cancel out, and this is 756.062622 millimeter of mercury. So from there, we can substitute. The pressure of the gas is simply 756.0622 plus the height, which is 10 millimeters. So this is simply 766.0622 millimeter of mercury. However, what is being required is the pressure in kilopascal. So, ibalik natin ito sa kPa. So, that is simply times 760 millimeter of mercury is equivalent to 101.325 kPa. So, this one and this one will cancel out. We are left with kPa. This is already 102.1332 kPa. This is now our answer.
Problem number 5. An open manometer is filled with mercury and connected to a container of hydrogen gas. The mercury level is 64 millimeter higher in the arm of the tube connected to the hydrogen. If the atmospheric pressure is 0.98 atmosphere, what is the pressure of the hydrogen gas in atmospheres? So the problem says that the mercury level is higher in the arm of the tube connected to the hydrogen. So we have here the tube, and then one is exposed to the atmosphere and the other one is connected to hydrogen. So this is our hydrogen. So it says in the problem that the mercury is higher in the arm of the tube connected to the hydrogen. So therefore, we are on this case. The pressure of the gas, hydrogen gas, is smaller than the atmospheric pressure. So pressure of hydrogen is equal to the atmospheric pressure minus H. So our atmospheric pressure is given to be 0.98 atmosphere. So we have to convert this into millimeter so that we can add the value of H, which is in millimeter. So this is 0.985 atmosphere. Convert it. So 1 atmosphere is equal to 760 millimeter of mercury. So atmosphere and atmosphere will cancel out, and then we subtract the value of H, which is 64 millimeter. Therefore, the pressure in hydrogen gas is 684.6 millimeter of mercury. However, what is being asked in the required is in atmosphere. So we have to convert this one into atmosphere. So times conversion unit, ibalik natin siya sa atmosphere, times our conversion unit, 760 millimeter of mercury is equal to 1 atmosphere. So millimeter mercury will cancel out. This is simply 0.9008 atmosphere. Answer.
Problem number 6. A closed manometer is filled with mercury and attached to a container of helium. The difference in height of mercury between the two arms is 213 millimeter. What is the pressure of the helium? So from this problem, since it says that it is a closed manometer, therefore the pressure in helium simply the difference in height of the mercury. So pressure of helium is the difference in height of the mercury is 213 millimeter of mercury. So if we want to convert our answer in kPa, we just use the conversion factor. So pressure in helium is simply 213 millimeter of mercury times conversion factor 760 millimeter of mercury is simply equal to 101.325 kPa. So millimeter mercury will cancel out and we are left with the kPa. So this is simply 28.3977 kPa. Answer. Now, if we want the pressure in atmosphere, of course, we simply have to convert. That is 213 millimeter of mercury times 1 atmosphere is 760 millimeter of mercury. Millimeter of mercury and millimeter of mercury will cancel out. And this is simply 0.2803 atmosphere. Answer.